Assalamualaikum. We are group 1 and this is our video assignment made for Sehidayat. It's the list of contents for our video. The first one is the group member, the introduction, problem statement and solutions, conclusions, and lastly, references. Next, I would like to introduce the group member, starting off with Aida binti Muhammad Rashidi. Second is Nur Maimah binti Mai Yunus. The third one is me, Nur Fazila Tasha binti Isam Mustafaruddin. And last but not least, Nur Camelia Elisa binti Badrul Halmi. Introduction to maximum and minimum point in mathematics. What is the maximum and minimum point? The maximum point is the highest point on the graph, while the minimum point is the lowest point on the graph. Saddle point is the point of a function's graph where the function's derivative is 0, which is a critical point, but not a maximum or the minimum point. We can use differentiation to solve maximum and minimum problems. Let's get deeper into the video.
The problem statement. The figure shows a jogging track in the shape of rectangle with semicircle on both ends. The perimeter of the track is 400 meters. A. Obtain expression for y in terms of x. B. Shows that the area of the track is given by A equals to 200x minus pi x squared over 4. C. Hence, determine the value of x so the area of the track is maximized. To answer the questions, first of all, we need to read the whole questions, and then as you can see here, the perimeter of the track is 400 meters. Based on the diagram, there's a rectangle part. The y is 2 lines here, and then the x is 2 lines as I highlighted here, and then we can see there is 2 semicircular part. To answer the first question, the A, to obtain an expression for y in terms of x, we should know the formula for semicircular. The formula for semicircular is 2 pi r over 2. And then we can just cancel out the 2, we got the pi r. After that, we can just write out what we already know. The given perimeter is 400 meters, and then 2y part, so y plus pi r plus pi r equals to 400, since we want to know the perimeter. And then just wrote out the whole equations back. 2y plus 2 pi r equals to 400. And then we got the equations. We need to know that r is also equals to x over 2. The full circle part is actually coming from the 2 semicircular, so the x is half, which is the diameter of the circle. We need to make it over 2, and then just write out the whole equations back and replace the r with x over 2 equals to 400. After that, just cancel out the 2. We got the 2y plus pi x equals to 400. 2y equals to 400 minus pi x. Just gonna take everything to the 400 side, so to get the y, since we want an expression for y in terms of x. So we got the 400 minus pi x over 2. That's it for question A.
Okay, so let's see for the question B. Show that the area of the track is given by A equals to 200x minus pi x squared over 4. So we need to show the answer to be like this. The first step is we must know the formula of the area of the track, which is area of rectangle plus 2 area of semicircular like shown in the figure. the area of rectangle is width times length. Like we see in the figure, width is x and the length is y. So we substitute the width times length with xy. Then area of semicircular is 1 over 2 pi r square. So we substituted it to the formula too. We can simplify the equation and we will get pi r square. Now we have three variables which are x, y, and r. We need to substitute r with x over 2, same line in the equation A, because we just want two variables of x and y, so it would be xy plus pi x over 2 square. X power of 2 is x square and 2 power of 2 is 4. So we will get xy plus pi square over 4. The y we can substitute with the answer that we get on question A, which is 400 minus pi x over 2. So we multiply the x with y. X times 400 minus pi x over 2, we will get 400x over 2 minus pi x square over 2 plus pi x square over 4. And we will get the answer same as in the question, which is 200x minus pi x square over 4.
Okay, C, determine the value of x that maximize the area of the track. So the first thing we have to do is the area formula. The area A is given by the formula A equal to 200x minus pi x squared over 4. This equation represents the area as a function of x, where x is variable affecting the track's shape. So second, we have to find the critical points to maximize the area. We calculate the derivative of A with respect to x. dA over dx equals 200 minus pi x over 2. We set this derivative to 0 to find the critical points. 200 minus pi x over 2 equals to 0. And then we rearrange this equation. Pi x over 2 equals 200. So the last answer we will get x equals to 400 over pi.
To conclude, the solution we use to find the values of maximum and minimum values are succeed. There are connections between apply maximum and minimum problem with differentials and how important it is in our life. With these applications, we can solve many mathematical problems in our daily basis, work and studies. That is all from us. Thank you.